Hi there, folks. Let me show you something. How many trees are within 1,000 feet of Keith Lane?
Let me look into that. I found 56 trees within 1,000 feet of Keith Lane. Some of the species include Monterey oak and crepe myrtle.
That just searched through 62,000 tree records, geocoded an address, calculated distances using spherical geometry, and gave me a natural language answer in seconds. Today, I want to show you how MariaDB Cloud makes building applications like this not just possible, but practical. Let's dive in. Here's the scenario. Imagine you're an Austin real estate company, or maybe you're a home buyer doing some research. Before you buy or rent a property, you might have questions. Is this a nice neighborhood? Are there trees, parks nearby? Is it safe? What's the traffic like? Any accident history? Are there restrictions? Historic district rules, flood zones? What construction is happening nearby? Traditionally, answering these questions means searching multiple city websites, downloading PDFs, maybe writing some SQL queries if you're technical. But what if you could just ask? Let's start with quality of life. Trees matter. They affect property values, temperature, walkability. How many trees are within 2,000 feet of 3711 Cedar Street?
Checking that for you. I found 140 trees within 2,000 feet of 3711 Cedar Street.
Look at the map. You can see where they are. The app found 140 trees and calculated the distances. That's a spatial query using MariaDB's geometry functionality. Let's try another. Anyone who's been to Austin knows it's a foodie town. How many restaurants within 1 mile of 2402 Hancock Drive?
One moment. I found 339 restaurants within 1 mile of 2402 Hancock Drive.
Great. Now let's check safety. Austin publishes Vision Zero crash data every reported accident. How many crashes have occurred within a quarter mile of 4705 Rosedale Avenue?
Let me look into that. I found 265 crashes that have occurred within a quarter mile of 4,705 Rosedale Avenue.
That searched through 220,000 crash records and found the ones within our radius. A buyer could use this to understand traffic patterns before committing to a location. But not everything is in structured tables. What about policy questions, rules, and regulations? Tell me about the Great Streets Master Plan.
Checking that for you. The Great Streets Master Plan, also known as the Downtown Great Streets Master Plan, includes streetscape elements and standards. It features element plans developed from 6 street types, suggesting appropriate furnishings for each. This draft plan was prepared in November 2001 by Black & Verneuil plus Kinney and Associates joint venture.
Good to know. That answer came from city planning documents, PDFs that have been chunked, vectorized, and stored in MariaDB. The app used vector similarity search to find the relevant passages and then synthesize an answer. This is RAG, Retrieval Augmented Generation. And here's the key point. Notice what just happened. We did spatial proximity searches, pointed polygon geometry tests, vector similarity search for documents, all in the same database. No separate vector database, no external geometry service. MariaDB handles vectors and spatial data natively. That's fewer moving parts, less complexity, and no data synchronization headaches. Let me tell you a little bit about what's under the hood. The data layer is MariaDB Cloud. We're storing 2.2 million construction permits, 62,000 trees in the city inventory, 220,000 crash records, 850 city documents, chunked and embedded for semantic search. 80,000 wildland urban interface zones. For embeddings, we're using a state-of-the-art model that creates 1,024 dimensional vectors. MariaDB's native vector column type and vec distance function make similarity search just another SQL query. Now, here's where it gets really interesting. RAG works by chunking documents and creating embeddings. But think about it. What is source code? It's just text. Functions, classes, doc strings, it's all text. So what if we vectorized the application's own code and added it to the knowledge base? Let me show you what that means. How is the MariaDB MCP server used in this application?
One moment. The MariaDB MCP server is primarily used to execute SQL queries, including complex multi-step and spatial queries for the application. It acts as an intermediary, processing requests from the application's HTTP client. Additionally, MariaDB itself is used as a vector store for ingesting and managing code knowledge.
How is the semantic router work?
Let me look into that. The semantic router works by first embedding your query using a local GPU. Then it uses that embedding to perform a vector search in a MariaDB database. It looks for the most semantically similar root among its stored anchor phrases. Based on the confidence of that match, it then decides the best path to take for your query, such as directing it to a knowledge base or a structured data query.
Tell me about the voice orchestrator.
Checking that for you. The voice orchestrator, specifically the streaming orchestrator, is responsible for managing the agent's workflow with streaming capabilities. It builds a LangGraph workflow that routes user requests to different tools, such as searching a database, querying a knowledge base, or retrieving code to generate a comprehensive answer.
Explain how spatial queries are executed in this application.
One moment. When you ask a spatial query, the system first uses the MCP SQL executor to detect it and extract any addresses. These addresses are then geocoded to get precise latitude and longitude coordinates. Once the location is identified, a spatial underscore query function is executed, searching for data within a specified radius in the relevant database table. The system also uses spatial indexes to make these queries very fast and even learns from past failures to improve future results.
So you can see what it's doing. It's describing the MCP server, the geometry calls, the result formatting. It's all pulled directly from the code base. And because we have a voice interface, I can just ask naturally. Real-time voice response. The fact that this works smoothly tells you something about MariaDB's query performance. We're doing embedding lookups, vector searches, and returning results fast enough for conversation. Any code base can become a knowledge base. So just a quick architecture recap. We have an edge server running the AI orchestration queries, managing the voice pipeline, generating embeddings on a local GPU. MariaDB Cloud handles all the data, the city records, the spatial geometries, the vector embeddings, one database, multiple capabilities. This whole system was built in about a week and a half. The hard part wasn't MariaDB, it was the prompt engineering and the UI polish. So what do we show you today? Spatial queries on millions of records, vector search for document retrieval, an AI assistant that can explain its own source code, all running on MariaDB Cloud. If you're building applications that need to combine structured data, geographic information, and AI capabilities, MariaDB can do it. One database, no Frankenstein architecture. We'd love to show you more and answer all your questions. You can find us at mariadb.com. Thanks for watching.